you know what to do in that good math. Okay. So our goal is, I can graph a quadratic function using the vertex and y-intercept method. Yes, Cody?
Did you just show the papers that were the second little bit that were on top of the table here?
No, they're the empty note ones.
Oh,
There's
just
for the
making
two
sure.
guys that aren't here yet. Okay, thanks for taking care of me. Okay, so we're going to not use the table method today. Today we're going to use the vertex and y-intercept method because, you know what? Every parabola has a vertex, right? And if you want to get a good U-shaped graph, you've got to find that vertex. That's a good place to start. And then we can use the y-intercept because every parabola is going to have a y-intercept, believe it or not. Everyone is. It's eventually going to cross the y-axis somewhere. And then we know that there's symmetry going on in these parabolas. So we should be able to do it. And I'm going to say we're going to do 5 points at least. Okay? So hopefully we can just get by with 5. So we are going to, I think the first thing I got to fill in up here is this part right here. This is really important. The y-intercept of a quadratic function will always be the c value of the function. So when the quadratic function is in slope, not slope, when it's in standard form, thank you, when it's in standard form, and you pick out the c value, you can say there's the y-intercept, there's the y value where it's going to cross the y-axis. I'm going to be able to go to the y-axis and put a point right there. Okay? So we're going to first find the vertex. So we have y equals x squared minus 6x plus 9. What's our a value? 1. B? Negative 6. C? 9. Today we need all of them because the 9 is what again? The y-intercept. A and B, what do we need that for? For the vertex, over that whole equation, x equals the opposite of b over 2a. Okay, so we're going to do our substituting into the our little formula to find our vertex, the x value of our vertex to start with here. I just wanted to see what I was leaving room for here. Okay, so we're going to do it underneath here. So the opposite of our b value is negative 6. Our a value is 1. Some of you are doing it just a little bit differently. You're giving that negative sign to the b value right away. And you're saying, I'm going to take the opposite of b. You could do that also. I'm going to leave it to the end here. I have negative 6 over positive 2, which that becomes negative 3. So I have the opposite of negative 3. What is the opposite of negative 3? Positive 3, right? Okay. So we now have, actually, the axis of symmetry, right? That's our axis of symmetry, but that also tells us then that it is the what?
Vertex.
X value of the vertex. It's not the whole vertex, is it? Yeah, it's just the x value of the vertex. So we now know that x equals 3, and we're going to sub into our function y equals x squared. We're going to change this to add the opposite, plus a negative 6x plus 9. So we're going to sub into our function and get our y value for the vertex, just like we were doing in those last 6 problems of the homework for today. Is that 3 have to go in parentheses when we square it?
No, that was negative.
Right, if it was negative, it would have to, right? So you can, or you can choose not to, because it is a positive x value this time. So y equals 3 squared, 9. Negative 6 times 3.
18. Oh, negative.
Negative 18. No calculators. Okay. Order matter when you're adding?
No.
Okay. So I can take those 9s and bring them together because I say, you know what? 9 plus 9 is 18. So I have 18 plus negative 18. Y is 0. So the vertex is
3, 0.
3, 0. Okay, write it as an ordered pair. That's our first point. Let's get out of the graph and just put it on there. 3, 0. Our vertex is on the x-axis, isn't it? So that tells us already how many zeros are there for this function. Only one. It's the vertex. Vertex doesn't have another point. one gonna open up or down?
Up. It's gonna open up because the AX squared.
Well, no, we should know before we get going here so that we can anticipate what should happen. Cody?
It should open up because your AX squared is not negative.
Okay, so your A value is not negative, it's positive 1, so this should open up from that. Our vertex should be the lowest point on it, we should be able to get a minimum from it. Okay, what's our y-intercept?
9.
Okay, but how do we write that as an ordered pair? It's like our second point.
0, 9.
0, 9. The C value, remember, is our y-intercept. So that's another ordered pair to go put on our graph. Okay. Now, did we find the axis of symmetry, by the way?
Good.
What is it again?
3. Oh, actually.
X equals 3. That is what on a graph?
The vertex.
No, what is the x equals 3 on the graph?
X is
A vertical line. It's the axis of symmetry, so I want you to take this ruler right now and I want you to draw a dashed vertical line. You're going to have to kind of make it, darker than the grid line is on the thing so that through the vertex. So you're going to draw the axis of symmetry because it's going to help us do the symmetry. I got to do that. That didn't go so well. Again. Must be a little bit off of calibration here. It's going to the right of it, isn't it? Oh dear. Come back here. Right there. Okay. Hope you're drawing your axis of symmetry is going better than mine is. Okay. Now, that axis of symmetry, just like it says, symmetry, any points other than the vertex, because it's going through it, any points not on that axis of symmetry have another point symmetric to it on the other side of the axis of symmetry. So we're going to get to use the axis of symmetry to get a third point. We don't even have to do any work. All we got to do is say, this point, the y-intercept, is not on the axis of symmetry. It is 3 units away from it, so what do? I go to the axis of symmetry and go
6.
3 over and put a point.
That's 6, 0.
That's
6, 9.
Not at 6, 0, but 6, 9, yes. Now I got 3 points.
2 more.
But I'm going to say that 3 is not going to be enough. We need 2 more, yeah. Now, I say for this one, pick an x value between the y-intercept and the vertex so that we can plug it in and get another point. The reason I say pick it between the vertex and the y-intercept this time is because they're so far apart. Okay? They're a ways away from each other. So let's find one that's in between them. So how many x values do we have to choose from that are, so the x value of the y-intercept is what?
0.
And then what x value of the vertex
6.
is?
Or
X value of the vertex is
3.
3. So we're going to pick something between 0 and 3. What do you want to pick? 1/2?
2.
2? Okay, let's pick 2. So we're going to say when x is equal to 2, so you have to pick an x value. You get to pick an x value, but now it's narrowed down and says, you know what, pick one that will help you stay, in a part of the U that we can actually see. So since these two are so far apart, it would make no sense to go over here and pick x equals 8, because we know it's going to be up there off the graph. So we're going to pick something that makes sense. So we're going to use 2. So we're going to go y equals 2 squared plus a negative 6 times 2 plus 9. Go ahead and finish that up. Get your y value for x equals 2. I don't like the choice we made, but it's okay. Did you get y equals 1? So now we have another point, ordered pair 2, 1, because we picked x value of 2, our y value turned out to be 1. Did you get that? Am I right or wrong? Okay, so now we're ready to go put that one on the graph, 2, 1. I wish we would have picked x equals 1, because I think it would have been not quite so close to this one, but it's okay. What do we do at that point now?
Do the same thing
Yeah,
on the
we-
other side.
Yeah, we reflect it across the axis of symmetry and say, okay, there's another point that's symmetric to that one. So this one's 1 unit away from the axis of symmetry. Its symmetric point is going to be 1 unit to the other side. Now we have 5 points. We can draw our U-shaped graph. And we look like geniuses that we knew which x values to do. Okay, any questions? Let's just do some mental math and see what the x equals 1 would be. 1 squared is 1, and then negative 6 times 1 is negative 6. What's 1 plus negative 6? Negative 5 or positive 5? 1 plus negative 6? Negative
5.
Negative 5. Negative 5 plus 9?
4.
4. Let's just see if that looks like it. But you don't have to do it necessarily, but I can do it. Oh, look at there. There it is. We would have chosen x equals 1 instead of x equals 2. And we've gotten a point that's on our graph. And then we could have reflected that one. That one's 2 units away, so we would have gone over here and reflected it 2 units on the other side. So here's the thing that everybody needs to hear me on this. We all have to find the vertex. That's got to be one of our points. That's not optional, okay? We all have to use the y-intercept as our second point. We're going to use symmetry of the y-intercept. We're going to find its symmetric point to get the third point. Unless there's a little bit of a problem, unless the y-intercept also happens to be the vertex. Then we have a little bit of an issue, okay? Here, then, after we did the y-intercept and its symmetric point, then we had to decide, okay, what would be a good choice of an x value for me to choose? Now I'm going to have to do some thinking on my own. I'm going to have to pick an x value that's going to help me get a fourth point to sub into the and get the y value for, put on the graph, and then I can use symmetry to get my fifth point. Okay? Questions? Okay, let's go try the other one then that I have for us to practice. Go ahead, identify the A, the B, and the C, because we need them all. And then first and most important one is the vertex. And you know what we're going to do that I didn't do last time? What we should have done is, you know what? We should draw the axis of symmetry the very minute we do the vertex, because here's the deal. Sometimes we mess it up and we think the y-intercept is our vertex, and we do our symmetric points wrong. So, you know what, once we get the axis, the vertex, we should be able to draw the axis of symmetry right away. So let's go ahead and find our axis of symmetry, also known as our b value of our vertex. So x equals negative, that's 6 over 2 times negative 2 this time. This would be one that would be good to change it to either a mixed number or a decimal if it's a nice decimal. I'm going to do the mixed number, I decided after all. Just for the ordered pair part. But then, I guess it's probably going to be good to use it as 3 halves when we are substituting into our equation to get our y value. So 1.5 is how we're going to refer to it in our ordered pair name when we find it. 3 halves will be more useful for finding the y value. So we have x equals 3 halves that we're going to put into y equals negative 2 times x squared plus 6 times 3 halves plus 2. This is where I don't want you to resort to a calculator right away. I want you to process guys trust your calculators way too much. Sometimes I think you get better answers if you did it on your own. So, y equals that negative, which is going to stay there. What does 3 halves squared become? 3 times 3?
3, 4,
9. 2 times 2? 4. We're really taking 3 halves times 3 halves. 3 times 3, 2 times 2. And then, over here in this one, let's put that 6 over a 1. What's going to happen there? You know, maybe the best thing to do is just multiply it and then we'll simplify later. What's 6 times 3? 18. What's 1 times 2?
12, or 2.
2. And then we got our plus 2 at the end, right? Okay. Now it's going to be useful if we put this over 1, right? Y equals, what's a negative, first of all, times a positive?
Negative.
Negative. Okay. Negative what? Okay, so you did this, I'm going to guess. You went 1, 2. Is that what you did? Okay. 2 goes into itself once, goes into 4 twice. 9 over 2. Okay. What is 18 over 2? 9. And then we get our plus 2. Okay, what's another name for negative 9 halves?
6 fourths.
No, a name that would be, you know, maybe a little bit more useful. It's not 6 fourths, by the way. Negative 4 and a half, right? So what we really have here is a negative 4 and a half. And then what's 9 plus 2? 11. Okay. So I'm just going to move here. I'm going to say that y equals. You owe somebody $4.50, and you say, I'm going to give you $11. I want to be to the good. So is it 6.5 or 5.5 or 7.5 or 7? 6.5. Go up to 5 is a half. Half up. Don't even worry about the sign right now because they're opposite sides. So we're just finding the distance between them. Halfway up would be a 5. And then how much distance is there from 5 to 11? There's 6. Now, is it a positive 6.5 or a negative 6.5? A positive. Okay, so what is our vertex? If I remember, we're going to do it so it's easier to graph. 1.5.
No, it's negative.
No, it's not. No, it's not.
Oh, wait, no, never mind.
Okay, I'm going to use blue so it shows up here better. So I have 1.5 for my x value, and what's my y value?
6.5.
6.5. Okay, so we're going to go to the graph right away, and I'm going to put that one on. 1.5, halfway between 1 and 2 on the x-axis, up to 6.5, halfway between 6 and 7. It's going to be floating in the middle of a box there. With my needing calibration here, it's not cooperating very well. Okay. What are you going to do with your ruler right now? Draw an axis of symmetry through it. Draw an axis of symmetry through it. Are there going to be any other points on that axis of symmetry? There better not be. The only point that can be on the axis of symmetry is this point. Vertex is the only point that can be on the axis of symmetry. So now we're going to go and decide what's our y-intercept.
2. That's our C value.
Our C value is 2. So that's ordered pair what?
0, 2.
0, 2. Identify these when you're doing your homework too on your work page. Just take the time to identify everything so that when you look back, you're like not get so confused. So the y-intercept, now we're going to go to 0, 2 on the y-axis and put that point. We're going to reflect it across the y-axis. How far away is it from the axis of symmetry? 1.5 units away from the axis of symmetry. So we've got to go 1.5 over to the other side and put our symmetric point. Now, I do not want a little stretched up u, so do you think I'm gonna let you pick any x values between the y-intercept and the vertex this time?
No.
No. So what we're gonna do is we're gonna go pick an x value that would get us a point over here, down here to the left somewhere, or we're gonna go to the right, because we wanna go, we want one that's down further. So pick the closest one you can to either end. You wanna work with a -1, or do you wanna work with a +4? Yeah, I do too, thanks. Making a good choice there. So I say between the vertex and the y-intercept, I want you to, see, pick an x value. No, cross that out. This time we don't want it between the vertex and the y-intercept, because the vertex and the y-intercept are too close to each other. So pick one outside the y-intercept this time, or its symmetric point. So they don't always have to be between the vertex and the y-intercept. You can pick other ones, and we're picking 4. So go ahead, put 4 in and get the y value, because we've been doing this now. We don't need to help each other. And then look up after you have your ordered pair and see if we agree. Because we're all using the same x value, so we all have to get the same y value. Do you agree with me, or do you need to straighten me out? I have been known to make mistakes. Made a couple in my life. Did you get the same thing? Yeah, okay, so let's go put it on there then. If we're convinced we have the right one. So we're gonna go plot that one on the graph. Do we have to put another x value in? No, what do we have to do?
Crossover.
Cross over the reflect.
Yep.
So how far away is this one from the x-axis, or from the axis of symmetry? 2.5. So we got to go 2.5 the other direction and put a point. And now we have 5 points ready to draw our skinny little parabola. Should it open down?
Yes.
Why?
Because our
Negative, negative a value, right? It had that -2 at the beginning, so better open down. Yes.
Is the rest please?
No. Okay, are we good? Okay, let's do some homework here.